Question 11, Part D. Evaluate the integral of x over the square root of x minus 1 dx from x equals 2 to x equals 5 using the substitution x equals u squared plus 1. Let's start off with the substitution. Now we have x equals u squared plus 1. Now I'm going to rearrange this substitution to make u the subject. So we have u is equal to the square root of x minus 1. Now I'm going to call this equation 1. Now this is important because the limits of integration will need to be changed from being in terms of x to being in terms of u. And we'll do that later on. Now the other thing we need to do is to differentiate x with respect to u, because the differential dx will need to be written in terms of the differential du. So differentiating x with respect to u, we get dx du is equal to 2u, and then multiplying both sides of the equation by the differential du, we get dx is equal to 2u du, and we'll call this equation number 2. Next, change the limits of integration from being in terms of x to being in terms of u. Now from equation number 1, when x is equal to 2, u is equal to 1. Now this is our lower limit. And when x is equal to 5, u is equal to 2, which represents our upper limit. Next, rewrite the integral in terms of u. So the integral becomes u squared plus 1 in brackets times 2u over u du from u equals 1 to u equals 2. Now the u's will cancel here, and the 2 being a multiplying constant can be written outside of the integral. So that equals 2 times the integral from u equals 1 to u equals 2 of u squared plus 1 du. And that gives us 2 outside of u cubed over 3 plus u in brackets from u equals 1 to u equals 2. Applying the limits of integration, we get 2 outside of 2 cubed over 3 plus 2 in brackets minus 1 cubed over 3 plus 1 in brackets, all in brackets, making sure that the 2 is multiplied all the way through. And that equals 20 over 3.